So we're on page 316, and we're going to use that LCM knowledge to figure out these problems. So write this problem down to start off with. 7 over 3k plus 5k plus 1 over 2k squared. 2k squared. Okay, can we add these fractions like they are? No, because they don't have common denominators, or what they call like denominators. They're right now unlike. So I have to find the LCD of these fractions, which means I have to find the LCM of 3k and 2k squared so that I can get a common denominator. So does anyone know what the LCM?
6k squared.
6k squared. Any questions on that? That's the LCM of those two denominators, 6k squared. All right, what that means is I want both of these denominators to be 6k squared. So I'm going to rewrite the fractions so that the denominator is 6k squared, because then they will be like, and then I can add them. But how did I get 3k to become 6k squared by multiplication? What did I multiply 3k by to get 6k squared? 2k. So I have to multiply 3k by 2k. But can I just multiply the denominator? I have to multiply also the numerator by the same value. Does anyone know what 2k over 2k is worth? 1. So what am I actually multiplying this fraction by? 1. So what's 2k times 7? Okay, somebody, before I move on, tell me if I change the identity of the original first fraction when I change it to this. So are these two the same thing or not? They are the same thing. They have the same value because I just multiplied by 1. All right, what do you think I should multiply the second fraction by? Close. I think I heard a little extra. Just 3. Just 3 over 3, which is worth what? What's 3 over 3 worth? 1. Okay, what's 2k squared times 3? 6k squared. But be careful up here, guys. What's 3 times 5k plus 1?
15k plus
3.
Good. It's 15k plus 3. Wait. I thought you just do the 3 times a 1 or the 3 times a 5k. But remember, this is a sum. So what do you do with sums? You keep them together. So it's really 3 times both of those. It's distributive property. We get 15k plus 3. All right, do I have common denominators? Yes. So now can I add the numerators? Yeah. So it's 14k plus 15k plus 3. 29k plus 3 over the common denominator, 6k squared. Now, before you need to do this on all the problems. Make sure you can't cancel anything out. Can the 29 and the 6 cancel out?
No.
3 and the 6.
No. Because they don't have
Remember? Yeah, this 3 is linked up with the 29k, so unless I cancel that whole thing out, I can't. So that's as far as I can go. Well, can I factor out the numerator? Maybe that would help me out. Is there anything that is common to the numerator? GCF? Nope. So that's it. K cannot equal.
0. Wait, yes, you were correct.
K cannot equal 0. How did we get the K cannot equal 0? What a great question. Look at your common denominator, and you can look at one of them. What can K not be in that denominator? It cannot be 0, because if K is 0, what's 0 squared? 0. Times 6? That's bad. 14K over 0? Not good. Or technically that would be worth 0 over 0? Not good. Ask your calculator. Okay. No, guess not. All right. Let's do another one. 3p over 7, I believe it's 7q. Excuse me, 4q. I'm so sorry. I know. But if you're using pencil, this is fine. Oh, that's true. Not the slowness part. Not the slowness part. Okay. Anyway, here's my problem. Can I subtract these as they are? No, because they don't have a common denominator. So really, all you're trying to find out, so Jensen and anyone else who didn't finish the homework, you're trying to find, all you're trying to do is get the LCM of those two. So what's the LCM of 4Q and Q?
4Q.
It's 4Q. That's the LCM of those two. So what do I want both denominators to be? 4Q. No, yeah, you're fine. You're not in trouble. Or I'm not calling him out. I'm just saying if he didn't, or if you did it, if there's somebody else, that's what you would have to do.
That's fine. You say.
What do you multiply the first fraction by?
1.
Yeah, you multiply by 1 over 1, which gets me 3p over 4q. What do you multiply the second fraction by? 4 over 4, which gets me 28p over 4q. I have common denominators. Now I can add or subtract the numerators. So what's 3p minus 28p? Negative 25p over 4q. And can I simplify anything? No, so you can leave it alone there. What can q not equal?
0.
What can p not equal?
Anything. It cannot equal nothing.
It should equal.
So there are no excluded values for p, so that you're not even asking that question, but why? I mean, that's a variable. Good. You could say it's in the numerator or it's not in the denominator, so I'm not even worrying about what p cannot be or what it can be. It could be anything. All right, good. Awesome. You guys are doing well with this.
Thank you.
You're welcome. Here's your reward. Try these, number 1. On page 317, try these, the bottom. Number 1. 11. 11 over 8t squared plus 1t over 12t cubed. Let's see if you guys can find something in this problem. If not, cool. If you do, great. But I'm trying to find the LCM of 8t squared and 12t cubed. So what's the LCM of 8 and 12? 24. The 8 and 12, smallest number that fits both of them is 24. T to the third. Yep, t cubed.
T to the cube.
So that's my common denominator. So I want both denominators to be 24t cubed. 24t cubed. What did I multiply, Rachel, the first fraction by to get 24t cubed in the denominator? 3t over 3t, which everyone is worth? 1. What's 3t times 11? 33t. Sarah, what do I multiply the second fraction to get 24t cubed?
2t. No, wait. Yeah. No, just 2.
Yeah, 2 over 2. That gets me 2t over 24t cubed. All right, and then I add those two because now they have a common denominator, and I get 35t over 24t cubed. That is not all because that's not as simple as it can get. What can be canceled out? A t here and a t there. So you would get 35 over 24t squared. What can t not be?
0.
Wow, t's not liking, or the variable's not liking 0 so far, right? Is the excluded value always 0?
No.
No. So far it has been, but it's not always the case. We'll see what happens when it's
The
not.
only thing I was going to ask is if the exponent is 2 or greater, is it always not going to equal 0? Because you have to square root every time, right?
No. Okay, great
It
question.
doesn't have anything added on to it.
Yeah, if it's just a monomial with an exponent, with a variable, and it could be any exponent, it's going to be variable cannot equal 0. So the way I found out, honestly, the way I found it out for any problems, I just say 24t cubed cannot equal 0, right? And then you divide both sides by 24. You get t cubed does not equal 0. How do you solve for that?
You cube root.
You cube root both sides. Sorry, that's a cube. Ooh, that's better. All right, so you get t does not equal 0.
Wait, so
Wait, so if it's a monomial.
Monomial in the denominator.
Is 2 or greater.
It's if you have any variable. If you have any variable to the second, third, fourth, fifth, it's going to be that variable cannot equal 0. Yep, because if this were just, for example, nothing there, 24t, it'd be t does not equal 0 still. So any variable to any power when you just have a monomial.
so if I have like 8t on like the original problem to like the 32nd, so how do I get? So I'm supposed to get 32 answers. How is that possible? Do I just get a ton of zeros?
Yeah, you just get a bunch of zeros, which are all.
Okay.
And it's a bunch of positive and negative zeros, which they all just give you 0. How many of you got that? These two. Okay. So far, we've been dealing with monomials in the denominator. And that's okay to get, and we will get some of those, but you don't always get that. Yeah, I know. Tell me about it. -4 over x squared minus 4. So that's my change. Plus 1 over x minus 2. All right. I'm going to change a little bit of how I taught with them. Sorry, guys. I don't know where that Bible maybe. Okay. So what I want you guys to do is when you have non-binomials, right? Or sorry, non-monomials. We have a binomial. You could have trinomials. I want you to factor out those denominators. And we've done that a lot, I hope. So you get -4 over, how do you factor that out? X plus 2, x minus 2. Those could be switched, but it's a difference of 2 squares. And hopefully you guys are getting quicker on that. Plus 1 over x minus 2. And that can't be factored. So close to being factored, but not. All right, can you add those up as they are? No, because they don't have common denominators. So you're trying to find the LCM of x plus 2 times x plus 1 and x minus 2. Sorry, I wrote that wrong.
X plus 2.
Yes.
I'm 2.
See, it's that hard. Okay, those are my two numbers that I'm trying to find the LCM of. All right, here's how I'm going to put it, and then I'll show you an example of how you've been doing this for fractions forever. All right. How many factors are up here? 1, 2, 3. Do you guys agree with that? 3 factors? Okay. How many unique factors? How many one and only factors?
1.
Ooh, I see what you're saying. Okay, how about this? I think the 1 is the x plus 2, right?
Yep.
Okay, but do you see how x minus 2 is another factor? But I know it's used twice, but the 2, they're called unique factors, or x plus 2, x minus 2. You see where I got that? Those are the only 2 ones I'm using. Out of all 3, they're just x plus 2, x minus 2. Okay. How many times do I use x plus 2 in this number? Once. How many times did I use it here? No times. I have to use it the most number of times it's used in either number. So how many times is it used here? X plus 2? Once. How many times here? So I'm going to use it 1 time. That's the most number of times it's used. All right, how many times is x minus 2 used here? Oh, sorry, right here. Once. How many here? Once. So how many times should I use it? Once. That's the most number of times it's used. Guys, this is a number. It's some number. And this is another number. So that I'm asking, how many times was x minus 2 used in this number? Once. How many times in this number? Once. How many times is it used the most? Once. And you're like, whoa, let's follow up on that. Great question. A squared BC cubed. Write these down kind of like separately. And then A, B, C, D. And yeah, let's go here. All right, let's pretend we were doing this LCM, right? How many unique factors are up here? How many variables? 4, right? A, B, C, and D. You guys agree with that? All right, how many times is A used in this first number? Twice. How many times is it used here? So how many times should I use it? Twice. Good. How many times is B used here? Once. So I'm going to use it once. How many times is C used? 3 and 1. So I'm going to use it 3 times. How many times is D used in the first one? 0. How many times is it used in the second? So I'm still going to use it only once. That is the LCM of those two. So you're doing the same thing up there. It's just weird because they're binomials. Phew. That's my bubble thought process of why I did up there, what I did up there. I want both denominators to be what? X plus 2 times x minus 2. Do you agree with that? That's the LCM? We said that was LCM? Okay. So here this next, hopefully it's not too confusing. I want them both to be x plus 2 times x minus 2. Okay, right? I want them to both be that. What did I multiply the first fraction by to get that? 1, right? I didn't have to multiply really by anything, and if I did, it was just by 1. So I multiplied this by 1 over 1, right? By the way, every fraction this morning, we've multiplied by 1, just in different forms. Sometimes 1 over 1, sometimes 2x over 2x. It doesn't matter, but it's 1. What do I multiply the second fraction by to get that? Good. X plus 2 over x plus 2. So I'm going to multiply by x plus 2 over x plus 2. And what's x plus 2 over x plus 2 equal to?
X plus 2.
It's just 1. X plus 2 over x plus 2. It's a big fat 1. All right, do you see how I got the denominator? It's right here. What's the numerator? X plus 2. Yay. All right. Do I have a common denominator? Yes, I do. So can I just add the numerator now? Yeah, what's negative 4 plus x plus 2?
X minus 2?
X minus 2. Yeah, you can say x minus 2. And where am I going to fit that in? Oh, right? What's negative 4 plus x plus 2? So you're just adding like terms. I'm going to erase this right here. And that's x minus 2. If you write it in standard form, over x plus 2, common denominator, x minus 2. Yay!
Wait, you can cancel.
What? Oh yeah, that can cancel. So what are you left with now? 1 over x plus 2.
I forgot. Where do you go to do your excluded values? So if I did it from the original, it'd be different from that I did it from the factor.
Okay, it's actually, you can do it from this. Get it from the LCM of the two denominators, because that's always going to give you all the numbers. So from here, what are the excluded values?
Negative 2 and 2.
Yep, there are 2. Negative 2 and 2. So please write this. Excluded values matter. Actually, they don't. Wait, they do or don't matter?
Not right now.
No, they do. Okay, does x not equal 0? Is an excluded value 0? No. Can x be 0 then?
If we put it into the original, or no, it didn't.
The question was, can x be 0? Let me ask that question again. Can x equal 0? Yes. But the denominator cannot be 0. Yeah, you see the difference there? There's a difference between the denominator and then the variable. And hopefully you guys will distinguish that. All right, let's go with this one here just to kind of review. Example number 1 on page 317. G minus 1 over 2g plus g plus 3 over 6g. All right, so we're, again, just reviewing the first type of problem.
This is so much easier.
Okay, hopefully, yeah. Hope you guys get, don't forget, g minus 1 is one thing. G plus 3, one thing. Don't just split it up without factoring. What's the LCM of the denominators? 6g. So I want to make both denominators 6g. What do I multiply the first fraction by?
3, or just 3.
Just 3, right? Just 3 over 3. So what do I get in the numerator? Careful. 3g minus 3. Because it's a binomial, you keep it together, you can even do this. What do I multiply the second fraction by? 1. Mr. A, didn't I also multiply the first fraction by 1? Yes, in a different form, which is okay. All right, do I have a common denominator? So add the numerators and get me something. Don't say it out loud. Add the numerators.
Why is it 4? I think it's 3G. What? I thought it was
Alright.
3G squared.
Well, what are you doing with these two? You're not multiplying them.
You're adding them.
So it's 3g plus 3g plus g. 4g.
4G because there's a 1 in the...
Yeah, and then what's negative 3 plus 3? 0. Canceled out. Common denominator. That's not my answer. This can't be my answer. It seems too big. Nick, what cancels out?
The G's and
The G's and the 2 that comes out of those. 2/3. That right there, the original problem, is worth 2/3. What can G not be? 0. Oh. And Marissa, for you, we have a monomial. So, and with a variable, any power, G does not equal 0. It could have been G squared, G to the third, G to the whatever. Okay. Are you asking for this problem right here? I want you guys to, you can work with people around you on this one, but don't be too loud and don't goof off because that's the solve. Sorry. This one is has a lot of steps, as you've noticed some of these can. I want you to subtract these two. You can work with somebody around you.
Wait, so
My first job when I have a binomial or trinomial in those denominators is to factor the denominators. Factor those denominators. I'll give you that first step. All right, so 1 over, what factors out of this? GCF. So sometimes it's a GCF, sometimes it's a different to 2 squares, sometimes it's a trinomial, it just depends. What factors out of the second denominator? All right, I'll leave that to you guys now. Yes, ma'am.
Would you multiply this side by 3 and then you get 3y and then you change this side by y? Okay.
Now, how many times is y used in both?
Yeah.
So if you did how many times y is used in both, you wouldn't count them in each.
Yeah, so can I see
I don't
your
know if that
pen?
makes sense.
No, I think, okay, there's a y here and a y there.
Yeah.
But this is one factor.
Okay.
And then, so y is a factor and y minus 3
So I
is a
wouldn't say
factor.
like y is used twice there. It's just one.
It's just once, yeah.
Yes, I got it wrong. What's 3 times y?
That's a good question.
No, it was 3y. Times 1 minus 3.
wait, how in the world why?
All right, somebody tell me what the LCM of those two.
3y times y minus
3y times y minus 3.
Yes.
That's your LCM. So you want both denominators to be that. Yay.
Yeah, exactly. That made sense. Exactly. So I put myself in the problem.
What did you multiply the first fraction to get that denominator? 3 over 3. Right? That's why I multiply it. 3 over 3. So that gets me 3 over 3y times y minus 3. Okay, good. What did you multiply the second fraction to get that? Y over y, which gets you, you can say negative 1y or negative y. All right. Yes, ma'am?
Why wouldn't you multiply
multiply the 3 over 3 to the first, like, denominator, the one, like, the original.
This one up here? Because these two right here are the same thing. This one, factored out, gets me that. It's the same thing, though. But you want to use this to combine. All right, I get 3 minus 1y, or 3 minus y, over 3y times y minus 3. And I am not done with that.
Yes, I got it.
Hold on.
Negative 1.
Okay. I can't hear you, boo. Do you guys notice that these two look like they're very close to being canceled out? They are not, they cannot be canceled as they are, but they are opposites. Do you remember that? Opposites? One is 3 minus y, the other is y minus 3. How do I change that? Do you guys remember how I can change that?
Multiply by negative 1.
Okay, so I'm going to get negative 1 times y minus 3 over 3y, y minus 3. How many of you did that?
That's what I did. That's what I
You
did.
changed it. No, don't. You could have changed that. Yes, you could have changed that. All right, what cancels out? What am I left with?
That's what I got.
That's your answer. Davis, what can y not be? Cannot be 0.
And it helped.
Alyssa, what can y not also be?
Why is special on that problem?
Don't forget these excluded values.
They cannot even. I tried to put it in like a 2-year-old term.
Wait, when did you equal negative?
Sorry?
When did y can equal negative 3?
So here's your, or you can look, I mean, any one you look at, y cannot equal 0 and y can equal positive 3. Because 3 minus 3 is 0. All right.
Along with all the other.
Oh, that's it?
That's it. Yeah, and we have 3 other majors.
Well, yeah, no, we have like 10.
Take it one step at a time and start reviewing today.
And your homework day.
The final ultimate problem. I did not give this problem to the other class.
We're better. Did you get homework?
Mainly, yes, I did. Same homework you'll get. All right, so this is your last problem that I want you guys to do right now. And
Right now, the other class is gonna get this.
sorry? No, but they got started a little later because I have home base with them, so I take a little longer.
So why don't we just?
All right. I want to factor out the denominator. So the first denominator is fine. Factor it as much as you can. The second denominator is not factored out, but you can factor it out. The lead coefficient is 1, so then you get no, it's okay. Try another one.
X minus 3 x plus.
Minus 3 plus 2. Okay, what's negative 3 times 2? Negative 6. What's negative 3 plus 2? Negative 1. So those are the numbers. Those are the factors. All right.
Oh.
So we factored this trinomial, remember, has a negative 1x, to get these two binomials. Factoring is not going away anytime soon, by the way. Algebra 2, you're going to do this, like, you're going to keep factoring. Is this a difference of 2 squares? Is this a trinomial lead coefficient of 1 or any other number? Is this a 4-term polynomial? Do I factor by grouping? Do I switch the groupings around?
Yes, yes. You switch the groupings around to make GCF a lot easier.
Yes. And there are other ways to factor. The difference of 2 cubes. That's one of them. Oh, difference and sum of 2 cubes. That gets tough. All right. What's the LCM of those two denominators? X minus 3. X plus 2. So I want both denominators to be that. All right. What did I multiply the first fraction so that I can get that?
X plus 2.
So I'm going to do x plus 2 over x plus 2. So that gets me my denominator. And then what's x plus 2 times x?
X squared plus 2.
x squared plus 2x. By the way, keep the denominators factored. Simplify the numerators. So you can actually...
Why is x squared plus 2x?
Yeah, so what's x times x? X times 2. And what did I multiply the other one by? 1. What's the addition or subtraction now?
Guys, there's no way.
X squared plus 2x minus 3 over x minus 3. Whoa, that is not the simplified form.
Wait, what?
It isn't because guess what? X plus 2 goes into something.
Yeah. Can you factor this trinomial? The ultimate final last problem is almost complete.
It actually doesn't have.
All right, what's that factor to, first
X
of all?
plus 3 is x minus 1.
X plus 3.
Exactly, so it doesn't do it.
Just
Just wasted our time.
bummer. All right, you can leave it like that.
What? Bummer. But can't multiply by them.
Yeah, so here, you got to try it out, though, because I honestly thought it could have, but it didn't. Oh, well.
You get negative x.
If these were both x minus 3, you could have done it in this case. Leave it alone.
X cannot equal 3 and x cannot equal -2.
Ooh. Good job, guys. You just earned yourself another... No, you just get a homework assignment. You're welcome.
And then why is it
Number 7 and 10 are done for you, but you got to work it out.
Mr. A,
They have the
that's
answer.
very generous amount.
I'm not gonna
Bye-bye, swivel.